Welcome to Plutus STEM, and today we are covering the hydration of alkenes to form dehydration of alkenes to form alcohols. In the previous class we talked about how hydration of alkenes using acid catalyzed reaction can convert the alkenes to alcohols, and today we're gonna go for the reverse process of it. Okay, in last class we discussed that alkenes do not mix with water, so adding a little amount of acid puts the reaction in the forward direction where we can get alcohol, and today we're gonna do complete opposite to it. So first, before we move forward, we need to take into account two important things: that conversion of an alcohol, for example ethanol, conversion of an alcohol to alkene, that is your ethene or any other alkene that you want, or to ester, not ester but ether, they both can follow the exact same steps. Okay, it also utilizes a strong dehydrating agent like concentrated H₂SO₄ or P2O5 or aluminium oxide or aluminium. At the same time, this can also require the exact same set of reagent, no difference to it. So why we can get two different products? The only difference that you can get two different products is the sole condition of temperature. That if you are having a temperature of around 140 degrees Celsius to 160, a temperature of about 160 degrees Celsius, 160 degrees Celsius, which is roughly estimates to your 343 Kelvin. And if you are using temperature of 140 degrees Celsius, roughly a temperature of 313 Kelvin, you can get ether. In that, two alcohol molecules will take part into dehydration to give you ether, which is CH3, CH2, O. Other portion will give you OH and leave, and this will be CH2, CH3. So it is the temperature condition along with the reagent that you are applying to get different products. So since today we are focusing on conversion of alcohol to alkene, our prime focus will be based on these conditions. Okay, all of these reagents are your dehydrating agent and they can cause dehydration of alkene by removal of water to give you ethene or any other alkene that we are working with. Just like the previous case that we have seen, it has also a three-step mechanism. The first being the protonation of alcohol. So for example, if I have any kind of alcohol, whatever it is, okay, any alcohol that I'm having, the acid provides protons or H plus ions to the solution, where oxygen, being nucleophilic in nature because it possesses two unpaired lone pairs, this lone pair will attack the H plus, converting alcohol into a form called as protonated alcohol. This is called as your protonated alcohol, as we already knew about it. Protonated alcohol. Here, if you look closely here, wait, it should be extra hydrogen and there should be an extra bond. How? Now, for this portion, the important condition here, it should be that this carbon will be called as your alpha carbon, and at least there should be one beta hydrogen should be here. Okay, so here there should be at least one hydrogen, that is possible, otherwise the reaction is not feasible. Now, if I closely look at it, this what alcohol is now protonated. The oxygen is having positive charge and being so highly electronegative, this positive charge is not much stable. So what will it do? It will try to stabilize itself. So now to stabilize itself, it will go under dehydration. That means the protonated alcohol will lose water. The protonated alcohol will lose water. Now, before we lose water, the first question that should come into our minds, that here, which bonds need to be broken? The carbon oxygen bond has low electronegative difference compared to this particular bond. So in this case, the formation of water is much more favorable and dehydration is favored by higher temperature. So the temperature of 160 degree that we have utilized for the reaction will help this particular portion to break the carbon oxygen bond, so that finally water gets removed instead of removing the hydrogen here. And this will give us what? This will give us a carbocation. This carbocation now needs stabilization. Here, after the formation of carbocation, this carbon, which has alpha hydrogen on them, it can utilize hyperconjugation by transferring one of its hydrogen to the other side. And the higher temperature will favor that the reaction should not come in the backward direction, that after the transfer of hydrogen, it will lead to the formation of a double bond. And the proton that you have utilized in the very first step needs to be written back to the reaction solvent. So remember, whenever you are doing a mechanism, whatever you are utilizing, you should also need to give it back to the solution or the solvent. So last process is your deprotonation. So now we have formed a carbocation and there's one hydrogen. So we can transfer the electron from this hydrogen to this side to form an alkene right here. So out of different types of alkene, you can see that hydrogen after transfer we are getting an alkene. But the question arises, this is a carbocation. So different alcohols like tertiary alcohols, secondary alcohols, primary alcohols. Which type of alcohol will first react to give you an alkene? First, those alcohols which are tertiary in nature, the removal of OH group from that direction will give you a stabilized tertiary carbocation. So a stabilized tertiary carbocation means there are more number of alpha hydrogen nearby. So tertiary alcohols have the highest reaction rate towards the dehydration to form alkene. Then it is the secondary alcohol which has the second highest rate of dehydration to form alkene, and at the very end it's our primary alcohol like ethanol, which has the slowest rate of reaction for the conversion of alcohol. So I hope this would have cleared all your doubts regarding how dehydration of alkenes occurs, how the entire process is occurring, and what is the role of acid and the temperature in it. Now, this particular mechanism is very important as for your board purposes, because frequently board goes for either for the hydration or the dehydration mechanism, and you can see in the previous year paper that there's a distinct pattern that this question is asked one way or another several times. So it's very important for you to learn. So I hope you learned something new today. In case of any doubt, you can add it to the comment section, or any new thing that you want us to make the video, you can also add it to the comment. Thank you for joining us for today.